let's go ahead and get started with the first chapter of Unit 9, which is Retirement Income from Savings. Our objectives for today, I will calculate future values of retirement investments that are both single deposit and periodic. I will compare the tax savings by making contributions to pre-tax retirement savings accounts, and I will calculate an employer's matching contribution to a retirement account. Now, there's quite a bit of vocabulary in this unit. You're going to want to make sure that you've reviewed that before watching this video. Make sure that you're familiar with all of the vocabulary at the beginning of this chapter. Once you are, you can go ahead and click play and we can get on with this. So let's get started with the first one. It says Blythe is 40 years old. She's planning on retiring in 25 years. She's opened an IRA at an APR of 3.8%. It compounds monthly. She makes monthly deposits to the account of $500. How much will she have in the account when she is ready to retire? So, looking at our screen here, I've gone ahead and already written out the formula that we're going to use, which is our periodic investment balance formula. And it states B equals P times 1 plus R over N to the NT power minus 1, all divided by R over N. Now below it, I've itemized here what each particular letter represents. B is my ending balance, which is what we're looking for here. P is my principal periodic investment. R is my rate as a decimal. N is my number of times compounding or number of deposits. And T is time in years. So let's go ahead and identify what each of these are, and then we'll plug them into the calculator. So looking at this, the ending balance, that's what I'm looking for, so that's my question mark. It says that I am depositing $500 into the account every month. There are 12 months in the year, at a rate of 3.8%, so we're going to convert that to a decimal and put in 0.038. She wants to retire in 25 years, so we're talking 25 years for our time in years. Now, I'm going to go ahead and plug this into the calculator, and I'll tell you that many calculators operate differently. And so sometimes it takes a bit, and they can be a little temperamental. I'm going to try and get this in correct the first time, but let's see how it goes. And with you, you're going to want to also play around with your calculator and see exactly where those parentheses need to go when you're plugging in this formula. For this particular calculator, I'm going to start out with an open parenthesis, 500 times 2 more open parentheses, 1 plus 0.038 divided by 12. We're going to close that parenthesis. And then over here we've got a x to the y power, that's our caret, open parenthesis, 12 times 25, close parenthesis, minus 1, close parenthesis. All of that divided by, open parenthesis, 0.038 divided by 12. Close our parenthesis, and we get 249,762.86, which, believe it or not, is the correct answer. So $249,762.86 will be what is in Blythe's retirement account when she's ready to retire in 25 years. All right, for the you-do, which would have a greater effect on the final balance? If Blythe's account was half the monthly deposit or half the interest rate? So just to get you started here, half the deposit would be $250 each month instead of $500. Half the interest rate would be 0.019 instead of 0.038. So I want you to go ahead and plug both of those in and see which one works. When you're ready, go ahead and come back and see how you did. please press pause. All right, so first off, for the half deposit, when I plug it in just as I did the first time, and I'm not going to go ahead and use time on this video to do it, I will just tell you that the answer you should have gotten was $124,881.43 when making half of the deposit. When making or cutting the interest rate in half, I end up with $191,813.77. So it would have a much greater effect or impact if you were to cut your deposit in half than to cut your interest rate in half. So very important thing to understand as we're going through. The interest rate had less of an impact than the actual deposit that was being made. All right, example number 2. It says, suppose that Blythe's annual contribution was pre-tax. How much did she save in taxes in 1 year if her taxable income for that year was $72,500? So what we need to do is we know that 12 times in the year, because 12 months in a year, she made a deposit of $500 for a total of $6,000 in deposits that she put into the account. So if her taxable income was $72,500, and that's taking out the $6,000 in pre-tax, if we add it in, we find that her taxable income would have been $78,500. So let's look at the charts over here. 72,000 here, 500. We see that her actual tax would have been $14,475. And that's what it was, supposing that this was pre-tax. If it was not pre-tax, or if she did not make those deposits, she would have been here at $15,975. So if we take the $15,975 and subtract the $14,475, we find that she actually would have saved $1,500 in taxes if this was a pre-tax contribution. All right, on the you-do, please press pause. Go ahead and solve it. When you're ready, come back and we'll get started. All right, hopefully this was a pretty simple one. It says, suppose Jacob invested D dollars after tax. His taxable income for the year was A dollars. So taxable income is what he is being taxed on. And if we subtract the invested amount, we will get our answer. So it is A, which is our taxable income, minus D, which is our investment amount. And that is our equation. All right, example 3. Let me see if I can move that so you can see it a little bit better. And Chelsea is 45 years old. She plans on opening a retirement account. She wants to have $300,000 in the account when she retires at the age of 62. How much must she deposit into the account each month with an APR of 2.25 to reach her goal? So again, I've already kind of written it out here. And now we're looking at a periodic investment. It's a present value periodic investment is what we're looking at now. And so the formula for that is principal equals the B ending balance times the rate divided by the number of times it compounds or is deposited, all divided by 1 plus the rate divided by number of deposits, all to the NT power, which is that number of deposits times the time in years, subtract 1. So identifying each of my values here, she's looking for an ending balance of $300,000. We need to know how much she needs to deposit, so that's our unknown. The rate is 0.0225. She's looking at making that deposit monthly, so that's a 12. And the time in years, she's looking at 17 years. And if you're wondering how I got that, she wants to retire at 62. Right now she's 45, so that is 17 years. So let's go ahead and go back to our calculator. Let's clear our previous amount out. And again, I'll take a chance here and see if I can get this right the first time. So plugging it in, I've got open parenthesis, 300,000 times 0.0225 divided by 12. All of that divided by 1 plus 0.0225 divided by 12. And then it's going to be to the 12 times 17 minus 1. And look at that. It comes to $1,208.59. So basically, she's going to want to deposit, Chelsea's going to want to deposit $1,209 each month for those 17 years to reach her goal. All right, go ahead and press pause, solve this, and when you get ready, come back to us and we'll finish out. All right, which would result in a need for a larger monthly deposit, half the interest rate or half the time? So at half the interest rate, when plugging in to the formula, I would have to put in $1,335.13 per month. Whereas half the length in time, I would have to put in $2671.63. And so the larger monthly would be the less time period. All right, looking at example 4, it says Xander is a 50-year-old married man who files his taxes separately from his wife. He's been making monthly contributions to his traditional IRA. Last year, he entered into a new business and he decided to withdraw $50,000 for his initial investment. Xander's taxable income for the year, excluding the $50,000 from his IRA, was $97,000. How much did he pay in extra for taxes and penalties? So looking at this one, I will tell you that first thing we need to know is what his taxable income was. So we've got the $97,000 plus the $50,000 that he has to count as income that he withdrew from his IRA. So his taxable income is $147,000. Now at $97,000, we see here married filing separately that he was going to owe $21,539, and that's at the $97,000. So that's excluding the money that he took out from his account. At $147,000, we're going to go ahead and calculate that down below. You can see we have a chart here. And I'm going to go ahead and press pause and continue in the next video.